Welcome back. My name is Palaj Viswas, Assistant Professor, JS College of Engineering, Department of Mechanical Engineering. And today discuss the surface paths. And this is the subject of computer-aided design, and also this lecture number 14. The surface path. Surface path. Path surface are defined as surface generated using one or more curves that makes a closed connections. That is the 3D curves or existing edge of parts and surfaces can be used to create the path surface. The path surface is created that like your the which paths will be goes, and also during to this the 3D curves, also the existing edge of parts that likes the if the path surface is added as an intel shape, intel shape of an existing surface is here. The edge can have contract to or tangent connections to surfaces contacting the edge is here. Once the edge loop has been selected, the path surface will stitch a surface using the edge. The resulting surface may contain edges created from the surface stitched between the edge selections here. You can see this is the edge, and also this like is called the tangent path surface is considered according to this. That like the this is the on a curvature area you can see, and during to this the curvature you have to given the green shadow, and you can also that like a red arrowhead is will be seen to this the edge tangent path surfaces is here. That like the this is the on curvature will be considered, and also this will be the tangent path surface. And the path surface command browser option is here. That is the add as intel shape. The selection this option to add the path surfaces as an intel shape of the selected surface part. They're like only available for innovative parts also will be here. Another things, the tangent by contact to connected surface. What is the tangent by contact to a connected surface is here. The select this toggle. Select the toggle options. The prior to selections to set the connections types to the surfaces attached to the selected edge. For structured parts, the select in the sense on the displayed message to toggle the option is considered. And another things the apply to all or smoothly connected. The what is the smoothly connected? It is the select this option to turn all the current connections types of contact by tangent based on the settings of the tangent by button contact button settings will be considered according to this the path surface. That like your the command is used. The one is the add as IntelliSaves, second is the tangent by contact to the connected surface, and another is the apply to all or smoothly connected surfaces here. The how to create a path surface. The basically the select the path surface command from the surface fluent ribbon bar. The selected the edge that defined a closed loop connections. The this closed loop connections, and if adding as an IntelliSafe, use the contact by tangent options to control the connections types to existing surface connected to the selected edge. The which one is the selected, and this edge you have to connected. That like your the connecting types will be given is the connect to this the selected edge. Another things the use the apply to all to set the all to set that like the all the connections to contact or the tangents. That like use the right clicks is given, and on this right clicks on the display connections type to change. That like use the display connection, that like use the type to change the individual settings each and every individual settings will be changed by your this the right click, and that means you can see your the display. And also the select the OK button to complete the path surface. That like your the you have to apply the all the connectings to the connection to contact or tangents, and also this will be given to this the right clicks, and also the OK button with the complete path surface will be considered. You can see the optional is come where that like your the selecting on the option to add as IntelliSafe. That you have to that like your the selection option will be comes here, and also you have to given to this the add a yes IntelliSafe for innovative parts. That like your the IntelliSafe for this the innovative parts. And during period the innovative parts will allow the user to select an existing surface. Those surfaces exist, and also you have to record this the selecting on this surface and to add the newly created surface. Basically, when you have to add to this the newly created surface, that likes you have to consider the IntelliSafe for this the innovative parts, that this will be allow the user to select an existing surface to add the newly created surface as an IntelliSafe of the surface parts. Another things, the user can use this method to create multiple surface the IntelliSafes to form a closed volume safe, the which will automatically convert it to a solid safe. That like the IntelliSafe, this is a to form a closed volume safe will be comes here, the which will automatically convert it. This will be the automatically converted to a solid safe. This is during to this solid safe for normal solids modeling operations. So just like your the normal solid modeling operations is comes. Another thing is here, even though the shape is a solid, the surface IntelliSafes are still available to edit the shape. That is your the shape is solid, that's you can be easily available to edit the shapes. That like your the maybe near to solids will be considered according to your the options will come. And how to edit a path surface, the right click on the path surface in IntelliSafe. The basically this will be focused to this the your IntelliSafe, and also this is the found that like your the right clicks the on the path, that like your path surface is considered the IntelliSafe. The select edit options, that like your the select is the edit options to change the contact, the which one is the connected, that like your the change this contact tangent settings for individual curve settings. That like your the individual curve settings, right click on the contact, that like your the right clicks on this contact is given, and by tangent buttons to change the settings. That like your the change the settings, the which one will be considered according to your the select options, and that is the right clicks of this here, and you have to contact or this is the tangent buttons to change the settings. Another things, the select edit curve, against this will be select the edit curve to change or edit the curve definitions. They're like the to change or edit the curve definitions of the path surface. That is the of the path surface for structured parts. Structured parts edit the original curve. That like your the structural parts. That is the edit the original curve in the history structure to update the shape of the path surface is considered. That is the your edit curve. How we have to edit this curve? This is your the structure parts. This is the edit. This is the original curve in the history structure to update the shape of the path surface. The surface design process, that like the ironclad primary use of surface shape. Shape is for enhancing solid modeling creations. That like you have to consider according to your the surface design process, you have to record for this the primary use of surface shapes. You have to enhancing this the solid modeling creations. that like your the surfaces can be created using standard creations tools. That is your surface can be created that like your the using standard creation tools, that like the additional creations, that is the additional creations tools from existing space and from imported geometry, that like your the imported geometries will be comes during to this the surface design procedures, the where your the geometry is to be imports from this the which places, just like you will be required to understand the surface can be used for the following operations will be considered. The imports surface to be used as trimming operations on solid shapes, that like you have to record for this the few cases the solid shapes you have to record to trim, then you have to avoiding your the trimming operations, that like you have to curvature will be considered according to this the edge of the surface, then that like your the drawing you have to trim this solid shape. Another things, the create surface to be used as trimming operations on solid space shapes. This is the use at the solid shape. Another things, the create surface to from closed volume solid enhancing normal. That like your the create surface to from closed volume. That like is the solid enhancing normal solid. Modeling techniques also will be used. The basically the closed volume will be the difficulties, that like your the solid, and also the solid modeling technique is used during to this the creating surface to this from the closed volume solids. And another thing is here, the surface path is the fundamental building block for surface. The two variables u and v vary across the paths. The paths may be termed biparametric is here. The basically the during to your the parametric considerations, this is the biparametric surface is draw, that like your the surface path, and you can see this figure that like a uh, graph paper. Also you have to consider say different type of surface path is available on this like a graph paper, that like a waiver considerations will be here. The during to this the variety u and v, the parametric variables often lie in the range 0 to 1, and like your parametrics variables, that is the lie in the range of 0 to 1, the fixing the values of one of the parametric variables, that is your the fixing this value, the which one is the parametric variables results in a curve on the path, that like your the curve on the path. In terms of the other variables, in terms of this the other variables, that like your the isoperimetric curves is come here. The figure shows a surface with curves at the intervals of u and v, that is the of 0 is to 1 is considered, that like your the value is considered according to this the ratio is maintained, that like the isoperimetric curve is come here, the you have to consider according to this the interval of u and v, that like use the 0 to 1, and its surface path is seen here, that like your the different graph paper is be considered, that like your the graph papers, and again the these curves will be considered according to this the figure, the isoperimetric curve is seen. And the applications of surface path, the copying and pasting solid phase generated surface and organizing them in the same components. Basically this is the copying and pasting will be creating during toward the application of surface path, and during toward the solid phases, and also generated surface, and this will be generated the new surface, then you have to use the surface paths, and sometimes you have to require the new paths also will be generated, and also the new surface also will be required for generated, and also few cases will be required to giving some layer, and this will be comes that like your the copying and pastings also will be used your the solid phase generated surface and organized them in the same components, and HyperWorks attempts to select the ten, appropriate tendency settings also will be here. That like your the HyperWorks, this HyperWorks attempts to this the select of this the appropriate tendency, that like your the setting for the surface created, that like your the settings, and also your the surface created, but you can change the tendency, and that required that like your the tendency also will be changed by your the application of the surface paths. And another thing is the use and to append and deselect line, that like your the you have to use, and to append appears, and also the deselect lines also will be used by your the application of surface paths. And during to this the deselect lines, the respectively new surfaces are organized in the same component as the first line selected. That like the when you have to generate a new surfaces, that like your the new yes you have to prepare, that during to these systems the new surfaces are organized in the same component as the first line is selected. That like your the first line is selected, during to this the second line is selected, your the first line is selected, that like your the organized in the same components as the first line selected. Then when selecting individual line, that like your the individual line is selecting, the click or hit enter to create surface, that like your the when you have to record for this the selecting the individual line, that like your the click or hit enter to create surface used to switch between surface, that like your the in between of this the surface is switch is required. The path and surface extended modes any is already selected, that like your the path and surface, this is the creatings, and also the any type of extended mode is required, that likes your the all any is already selected, these applications will be done during your the surface path. And another things is here, the you have to find during toward the new page or the new surface is creating, new line is required, that like your the different shapes will be comes. Okay, and you have to find this type of applications. And previously you can see when you have to draw this the surface designs, then the you have to use that as like your the surface paths. The new generation surface will be required for this the design, and again you have to draw to your the new type of drawings, and also the different type of applications will be comes, that you got the which type of surface is available, that like your the bottlenecks we can see, the during your the bottlenecks drawings will be found, then you have to use the this type of applications will be considerations, because the different type of path will be required to draw, and also this the surface will be considerations according to draw this type of curves. And this type of applications will be done during to the application of this the surface path. You can find that like use the cones path. The cones path is the basically this is the comes from your the surface path generations, but the cones path in mathematics, a cones path is a type of manifold parameterization used in computer graphics to smoothly join other surface. Basically, this cones path is the comes from during toward the manifold parameterizations, and also this will be used in this the different type of computer different application of this the computer graphics, when you have to smooth curve is prepared. Suppose you have the different type of curvature works, and basically the different type of bottlenecks, and also the different type of solid designs will be done during to this the systems, and also the curvature arena will be produced during to this the application of this the Kunz path, and basically which places will be required, that like your the smoothly join from this the one to this the another, then other surface together, and this computational mechanics application, that like your the computational mechanics applications is comes particularly in finite element method and boundary elements method will be used. Basically different type of application of this your the finite element methods, and a few cases you can see that like your the computational mechanisms or mechanics, it is the application of the Kuhn's path, and you have to record for your the smooth curve is here, and also the smooth boundary is required, and the smooth joining will be required for this the one to this the another. Then you have to considerations according to your the Kuhn's path, and boundary elements methods to mesh problem domains into the elements, that like your the domains into this the element is considered according to this the boundary element methods. And Kuhn's paths are named after Stephen Anson Kuhn's, and 1967 is comes in your the design industry, that like your the names of this the Stephen Anson Kuhn's, and these curves will be introduced to this the your different smooth surface is creating on this the CAD industries or the design industry. This will be comes from this your the Stephen Anson Kuhn's. Anson Kuhn's, the scapulated surface often involve interpolations across an intersecting mesh of curves that in effect comprise a rectangular grid of passes. Basically, this is the sculpture surface, that like the different skull, that like your the skull on your head. This is the this type of surface will be often the required for this the interpolation across and the intersecting mesh of curve. Basically in our header zone, that like your the this type of curve or the this type of surface is required, that like or the that in effect comprise a rectangular grid of passes is here. Each boundary by four boundary curves will be here, just like your the each and every boundary you have to consider according to your the four boundary curves is the considers, and this is the all these things will be considered according to the smooth is here. The linearly blended cones, that like your the linearly blended cones is find. Kuhn's path is the simplest of for interpolatings between. Kuhn's path is the simplest for this the interpolatings between such boundary curves. That like your the this type of boundary curves will be here. This is the between such boundary curves. This path definitions techniques blends for four boundary curves, that is the CJU and DJV, and the corner points, that like the different corner points is the found concentrate the Pij of the path, which is the linear blending functions. The basically or the sculpture surface you have to consider according to your the blending for this the four curves, and this is the different corner points also will be concentrates according to this the Pij of the paths with the linear blending functions, and the during to this on this is the defined for this the on by on, and also that this will be the very smooth surface is required. Then you have to consider according to this the Kuhn's path. You can see here that this one is the Kuhn path is given, that like you have to given a equation the ft equals to 1 minus t, that is the gt equals to t will be given here, and the during to this Kuhn path that you have to previously discuss, that like your the different four boundary curves is the four boundary points also will be given here, ci u and djv. You can see here these curves also will be mentioned, that is the curvature c0 c1 and also d0 p0 and pb0 will be calculated is here, and again another things is considered the gt equals to t, and using the expression, that like your the expression is come here, the p vector ub equals to c0 vector the u FV plus C1 vector VU and the GV plus D0 vector V FU plus D1 vector V GU is here, that like minus the P vector infinitive FU FV minus P0 on vector FU vector GU minus P10 vector GU FV. This is the function of FV and also function of GU is considered, that like your the minus vector P11 function of GU and function of GV is considered according to your the expression of this type of Coon's path, and this from these equations you have to put in this value, the gt equals to t, that like the ft equals to 1 minus t, and then you have to putting this value, the different points will be, and also creating the different path, just like your the Coon's path. The application of Coon's path, you can see the residue indicates that the perspective of train and complexity will be come during to this the during to this the complexity of this the curve, then you can be applied on this the Coon curves. That like your the few cases you have to here the residuals and also the indicates, and few times the train complexity will becomes here, and the Coon's path is much more accurate than the classical interpolation method. That likes your the Coon curve is the, or the Coon path is the much more accurate than the classical interpolation method, and accuracy of Coon's path is about 3 to 7.30, 15.19, 3.66 and 40.07 times as high as accuracies of IDW, the natural neighbor spline, and KRIGING on average. The Coon's path defined a path from the four curves forming a closed chain. The applications contains the four examples to Coon's path. That like your the boundary curves in the example are constructed by parametric curves or the parametric cubic curves in here, that lies in Bezier and Hermite forms is comes here. The first example is in 3D and comparable to parametric bicubic surface is comes here. That lies your the boundary curves is in the example, that like your the constructed by the parametric curves, cube curves, and the few cases is considered according to this the Bezier and Hermite forms, and that like your the example of the 3D compatible to parametric bicubic surface is considered. Bicubic path is here. The bicubic path is used for surface descriptions defined in terms of points and tangents vector informations. The general form of the expressions for a cubic path is given by P u v u comma v is here. This is the function of u v, the summation of I to 0 3 j equals to 0 summation of k I j u, the on v u I v j is here. This is a vector equations with 16 unknown parameters, that lies the kj, which can be found by Lagrange interpolations through, that is the 4 into 4 grid. The B-spline surface is given here. The B-spline surface approximately characteristics polygon as shown and passes through the corner points of the polygon where its edges are tangential to the edge of the polygon. This may not happen when the control polygon is closed. A control point of the surface influences the surface only over a limited portions of the parametric space of variables u and v, the expressions for B-spline surface is given. The application of Bicubic passes by taking set 4 cubic curves with the parameters like the s and using these 4 curves to generate a set of 4 control points of any given values of s, and then using those control points to define a parametric curve with parameters t, we can generate a surface called a bicubic path. The next class discuss in the Bezier and B-spline surface. Thank you.